video, I'm going to be talking about dying tumor cells, as well as dying T cells. So basically, they undergo apoptosis. This is important to deal with, especially preventing the T cells from even going through apoptosis, which I will explain some partial ways or some ways to help mitigate this, but it might not be the only ways, but there could be other ways. So the point is to stop the apoptosis, because if the T cells do undergo apoptosis, then they actually release ATP, and then tumors and cancer cells, they receive the ATP, they use it to create adenosine, and then the adenosine binds to the A2A or A2B receptors on other immune cells, and causing them to be suppressed. So tumors, they overexpress CD39 and CD73, and that allows them to convert ATP from apoptotic T cells and also other sources into immunosuppressive adenosine. So there are some other causes of tumor cell death, such as hypoxia, low oxygen, because tumors, they often outgrow their blood supply, insufficient oxygen, and then cell death. And then they release ATP as well, just like T cells. And then that suppresses the other immune cells that are left. Also, nutrient deprivation, because rapidly proliferating tumor cells consume glucose, amino acids, and other nutrients, leaving some cells starved. Which includes T cells. T cells could be starved as a result of those tumors consuming the glucose, amino acids, and nutrients, because T cells, they also rely on those glucose, amino acids, and other nutrients as well. And another way that ATP is released into the environment for adenosine to suppress immune cells is that because of immune-mediated killing on tumors and cancer cells, because cytotoxic T cells and NK cells, they release perforin and granzymes, which is actually that forces tumors and cancer cells to go under apoptosis, programmed cell death, and then the ATP is released to make adenosine. So this is why it's important to help support the immune system, which I will explain up next, to help keep up immune and T cell numbers and NK cell numbers, because they can be reduced as a result of the apoptosis on cancer cells and tumor cells, or which is the result or the outcome if immune cells dare to attack cancer cells, or causing them to go through apoptosis, because then that apoptosis, or the outcome of the immune cell attack on cancer cells, can actually result in less immune cells and a reduced number of immune cells, because of the ATP that is released as a result of the immune cell attack on the cancer cell because of the apoptosis. So that has to be buffered, or at least the number of immune cells have to be raised or increased to make up for the immune cell loss that could occur as a result of the apoptosis, creating the ATP from the dying tumor cells after the apoptosis that suppresses the immune cells. Okay, so T cells, they undergo apoptosis, or they have less numbers, because of the tumors robbing them of nutrients and glucose and fatty acids. So the goal here with healthy fats is to help improve the T cell function on the receptors. So immune cells, they have receptors that help them uptake, like interleukin 2, glucose as a fuel source, fatty acids, arginine and tryptophan, which are amino acids. Okay, now signalosomes can indirectly enhance immune cell receptor activity and substrate uptake, such as glucose, amino acids, and fatty acids. Also, possibly vitamin D as well, if inflammation is not downregulating the vitamin D binding protein. So signalosomes, they do not act as transporters themselves, but they modulate receptors and transporters, such as glucose, GLUT1 on cells, also uh, fats or fatty acid receptors on T cells, which are FATP and CD36. So signalosomes helps modulate or upregulate those for fatty acid uptake by T cells. Also, CD25 on T cells uptake interleukin 2 as a substrate for energy. Uh, Therefore, the T cells, if they are uptaking all of these substrates, glucose, fatty acids, interleukin 2, then they won't undergo apoptosis, and then ATP won't be released after the apoptosis, and then the tumors, they won't get the ATP to make adenosine to suppress immune cells. Okay, now I'm going to connect healthy fats with signalosomes, uh, because a membrane lipid composition is influenced by dietary fats. Um, so basically, lipid rafts are platforms for signalosome assembly. So consuming healthy fats can optimize T cell receptor signaling and immune responses. So there are healthy fats. They don't directly create signalosomes, but they optimize the membrane environment that allows signalosomes to be able to form. And possibly a really good one here is omega-3 fatty acids, EPA or DHA. They take the top spot for improving signaling quality, uh, therefore allowing signalosomes to form or at least supporting the environment for the signalosome to form. Therefore, T cells are less likely to undergo apoptosis if the receptors are forming that allows T cells to uptake substrate. Also, other monounsaturated fats, such as olive oil and avocados, also support the healthy membrane fluidity and stable environment that allows signalosomes to form, without making the membranes too rigid as well. Now, there are fats that can impair signalosomes, and those fats are trans fats, such as in pizzas, fries, burgers, etc. Also, excessive saturated fats, because they can over rigidify membranes. So the membranes can't be rigid, or else, if they are rigid, then the signalosomes can't form. So these trans fats and saturated fats will impair immune signaling. Also, something else to keep in mind is to avoid excessive fats of any kind, because excessive fats, even healthy fats, can reduce megalin, and megalin is needed for a cubulin to anchor, but that's beyond the scope of this video. I actually already made a video explaining what the megalin deficiency ends up doing if fats are too high, so you can check that one out if you want. So that's it for the video. If you're interested in more future videos, then make sure to like, comment, share these videos with your friends and family, and keep it locked in here on this channel, and I'll see you in the next video.